which is electric current. Now we continue with the subtopic of charged particles. So in charged particles, these are electrons and protons. So we have to know their charge, the charge of protons and the charge of electrons. We say electrons each carry a time negative charge of approximately minus or negative 1.6 times 10 exponent minus 19. So this is a charge of a particle. For the electron, it is negative charge, which is negative of this value or of this magnitude. So this charge is represented by minus E. So this is charge of electron, which its value is this magnitude. So the magnitude of the charge is known as elementary charge. So the magnitude of this is known as elementary charge. So for the proton, now for the electron, I've seen that for the electron is minus E. Now for the proton, positive charge, proton is plus E, which is positive charge. So this is how you can write the charge, the particles. So protons are positively charged with the charge of plus E. This equal and opposite to that of an electron. So this is equal and opposite to this of electron. So also the value of this one is equal to the value of electron, which is 1.6 times 10 exponent minus 19. So now we say charge is quantized. So we say charge is quantized. Charge is quantized. When you say charge is quantized, this means that it can only come in amounts which are integer multiples of the elementary charge. This means that it can only come in amounts which are integer multiples of elementary charge. Now, for example, we know that the magnitude of charge is E is equal to 1.6 times 10 minus 19 coulomb. So if we write the charge is 3.2 times 10 minus 19 coulomb, this means it's equal to, we have to divide by this value, so which will be, remember that this 3.2 means 3.2 E. We have to divide by this value, which will be 1.6 times 10 minus 19, which will give you 2. So it will be 2E. The value of E is this one. So if we times by 2, we get this value. So in this case, we say charge is quantized. This means that it can only come in amounts which are integer. So this is integer multiple of elementary charge. And also, let's say, for example, 4.8 times 10 minus 19 coulomb. You see, this is 3, because if we divide by 1.6, we get 3. This 3e. But if we put here, let's say 10 times 10 minus 19 coulomb, we say this is not possible. This is not possible because if you divide by 1.6, it will not give you the integer multiple. To give you number which is in decimal, or so we say that this is impossible. This is in this case the charge is not quantized. So the charge is quantized for the case that it is integer multiples of elementary charge. Which of the following quantities of electric charge is possible? Explain how you know. You see, A is 6 times 10 minus 19. You see, this one is not possible, because if I divide by 1.6 here, it's going to give the integer multiple. So this is not possible. Again, to this B, which is 8.0, also is not possible. It will not divide. If we divide by 1.6, it will not give us the integer multiple. Also the same to the C, which is 10 times 10 minus 19. So all these are impossible. So in this one, there is no quantity of electric charge which is possible for the quantized to be quantized because they will not give the, if we divide by 1.6, they will not give the integer multiple. The charge is quantized. Now, but for the fundamental particles, fundamental particles which are known as quarks. These are fundamental particles. Which are the building blocks from which particles such as protons and neutrons are made. So quarks or fundamental particles, these are the building blocks from which particles such as protons and neutrons are made. So those things which make protons and neutrons are called fundamental particles or quarks. It means the smallest materials. You see, electron is small, but it is made up by some particles which are very small. So we call those quarks or fundamental particles. So in this case, for fundamental particles, for the smallest particles, you see, we saw that the charge is quantized, but what for the smallest particles or charges, which are quarks, we say that these have charges of fraction. These have charges of fraction, like plus or minus. It means protons or electron, which is very small, the fraction of this one, or 2.3 elementary charge. So quarks always appear in 2s or 3. Quarks always appear in 2s or 3s. In 2s or 3s. So this is how quarks appear, in such a way that their combined charge is 0, or a multiple of E. Their combined charge is 0. So if we combine here, it's positive and minus. If we combine here, for example, for the positive minus 1 over 3e, if we combine this one to be positive 1 over 3e plus minus 1 over 3 elementary charge to be 0. So these are the quarks. Always appear in 2s or 3s, and the total for the combination must be 0, will provide 0 charge.